First three problems from last biweekly contests. I think it was 143. The first problem, smallest divisible digit product 1. So we are given n and t, and we want to find the smallest number greater than equal to 10 such that that number uh, product of its digit is divisible by t, right? So we can start from n and go until we find a number whose product of its digit is divisible by t. If we found it, then we'll return that number, and that's it. So I'll start as long as I can. Uh, so this will be an infinite loop. I will have a product variable initialized to 1, and I will have a variable I initialized to n, and I'll find the digits as long as I is greater than 0. I'll get the 1th place, and I'll multiply it with product, that will be I mod 10, and I will do a I by equal to 10 so that I leave the 1th digit, I divide it by 10, and at this point if the product mod t is equal to 0, then I'll break. Otherwise I'll increase the n variable and increment the n and return the number here. That's it. Let's submit it. So the second problem, maximum frequency of an element after performing operations, part 1. And the second the problem is also same, just there is a difference of constraint. So, and in this problem we are given an array called nums, and we are given two integers k and num operations, and we want to perform this many operations on nums uh, such that we end up getting maximum possible frequency of any element. And what is the operation? We basically select an index which was not selected previously and add an integer in the range minus k to k to that selected number. And we do that this many times, and eventually we try to do what the question wants, that is maximum possible frequency of any element. So if we take an example 145, and we try to see what is 1 and what 1 can be converted to, what all numbers can be converted to. So that range will come out to be 0 to 2, right? If k is equal to 1, right? Because 1 minus 1 is 0, 1 plus 1 is 2. Similarly, for 4, 3 to 5, 4, 5, 4 to 6, right? So we get a range for every number, and we want to see, or we want to find the maximum possible frequency for any element that we can change it to, right? So if we try to find the common element, the maximum occurring common element in the range, in the given range that we have found, that will be our answer, isn't it? So it's kind of a line sweep problem if you look at it this way. So for example, if you're given this, right? So this is the array, and we are given, suppose, a query. Suppose we don't have this, initial values are 0, or yeah, if this is the number and we are asked to do a operation on this number, initial values are 0, right? So if we try to do a query, right, if we try to do a query, actually These are not the initial. This is the initial value itself, and the first query is from index 2 to suppose 6, right? From index 2 to 6, increment 1, right? Yeah, increment 1, increment by 1. And similarly, the second query probably will be 6 to 10, increment by 1. So if I do increment from 2 to 6, one way is to do a traversal from the given in the given range and increment it literally. That will be a O of n operation for each query, but that is not efficient. What we can do is we can have an array called a array as it is. Initial values are 0, and at the extreme points of the query, that is 2 and 6. So at 2 I will increment it by 1, at 6 or the last ending index, one ending index after that. So at 7th index I will decrement by 1, so that I will end up having its prefix sum as 0 0 1 1 1 1 1 0 0 0, and that's what we wanted, right? We wanted to increment from index 2 to 6, and we have incremented from index 2 to 6, right? Similarly, we can do that same thing for this one as well. So at this point 6 and 11. So for 6 this will be a +1, and for 10, right? So after let's say we had an index here as well. In that case, if it's out of bounds, we don't even need it. And yeah, so this becomes 2, this becomes 1, the prefix becomes 1, the prefix becomes 1, right? So that's what we wanted, and that's what we got in its prefix. Similarly, we can do the same thing for this one as well, and for each number we will have its corresponding value like I had here. And if we look at it carefully, what does it represent? This particular value for each particular number, it corresponds to the number of operations that has been applied on this particular number, or on the entire numbers array to achieve these many numbers of this particular value, that is 6, right? So these are indexes. Let's remove this. So this particular value, it represents the number of operations performed on the numbers array to achieve two sevens. Alright. But is that true? No, that's not true, because I have also counted 7 as itself. You know, 7 in itself it's already 7, so we don't need to use any operations on that, but I have counted it here, right? I have counted it here, so I should not count it, and hence I should have this 2 minus 1 or 2 minus whatever the frequency of 7 is, right? So whatever value that I have achieved, I should have updated range value. Let's name this updated range value minus the frequency of the particular number in context. So frequency of nums of I, this will be equal to the number of operations performed on array to achieve nums of I as the candidate, or to achieve nums of I as the answer, right? So this is what it represents, but we had a limit, right? Number of operations, we already had a limit. So this will be let's name this current number of operations. But what I really need is, for every number there will be a sub answer, right? And that will be nothing but either this or the number of operations, minimum of the two, isn't it? Because if it takes 3 operations and I had a limit of just 2 operations, then I can only do 2 operations, right? So let's copy this. But there is one more thing. This represents the uh, let's leave it like this: total number of operations and let's name this as the current number of operations. Now I have a sub answer. This is not what I want as my answer, right? Or this is not what I want to contribute to my answer. I want to maximize my answer. This is not what I want to maximize. I want to maximize the maximum possible frequency. But this is the number of operations that is currently there. So I want the current number of operations plus whatever the frequency of the current number in context, right? So if there is, suppose this was suppose 5 as current number of operations, right? And suppose number of operations is 6, so I can have at least 5 operations. That means I am converting these to become 7, right? That is what is represented by this particular variable. But I also want the already existing numbers of 7, right? That is 5, or that is 1 here. Suppose this was also 7, suppose. Then I can convert these remaining elements to 7, but I already have 2 7s as well. So I should also add to this the number of frequency in context. Right, so this is what my sub answer would look like. My answer will be basically a maximized version of the sub answers, right? And I'll do this for all the numbers, and that's it. That's how we are going to solve this problem. Let's code it up. Initially, to find the minimum or the range, we can just iterate through nums and find the minimum and the maximum number, and that will be our range. So I will have a mini and a maxi initialized to maximum and minimum respectively, and I will also update the frequency in the first run because I will be needing it in the second run. Also, I need to update the query in the respective range, right? So this particular 2 to 6 needs to be updated like I told in this particular manner, in this particular prefix manner. So I can do that in a map and then process that map, right? So instead of an array, I can just have a map initially for the queries, for the updates. So let's have a range update variable, and that's pretty much it. Let's traverse the array and minimize the mini and maximize the maxi. Actually, minimize the minimum, right? That will be n minus k and not n. So let's be careful there. N minus k plus and n plus k. The maxi will be n plus k, and that should be maximized. Update the frequency, uh, and finally update the range update, right? That will be n minus k plus plus and n plus k plus 1, because like I said, we are trying to do it efficiently using the prefix kind of approach. And eventually, now that we have the range, we will go from mini to maxi, use the range update and find the prefix of it, and do these 3 4 steps and get my answer. So let's have answer initialized to 0, and since we are going to find the prefix, can just iterate from the mini to the maxi and get the range update prefix. So range update prefix now will be converted to its prefix, right? From its original value, that will be nothing but range update of I minus 1, which even if it is out of bounds, doesn't matter. Map will give me 0 value, so it's not going to affect my answer. So currently we are at this point, we have these updated range value, right? So we can now subtract it to get the total number of operations. So let's copy this, go here, remove this particular thing. Let's use this. Here it should be I instead of nums of I. So even if I is not present inside frequency, it doesn't matter. It's going to give us 0. So not going to affect anything. And this variable should be total number of operations, right? And that's pretty much it. Let's see if this works. Okay, there is some mistake. Range update of I, and there's this mistake as well. Nums of I should be I instead. Let's see now. Okay, there is a semicolon missing, and finally it works. Let's submit it. The third problem is very similar. So let's move to the third question. Third question is exactly same, just that the constraints are a little bit more strict. So we can use the same code, change it a little bit, and solve that. So let's copy this. So what we were really doing initially was to go through the entire range, right? We were going through the entire range. And that range was the minimum number of element in the number and the maximum number on the minimum number. That's what the range was. But do we really need to care about that? So let's look at this diagram to understand. So if I have this as a map, suppose this is the range, and then this is the range, and then suppose this is also the range, this is also the range, and that's it. So what we really care about is these overlaps is what we care about, right? I'm not able to draw it properly, but I hope you understand. So this, my mouse is not working properly. This is what we care about, this particular overlap, right? So if I have a map and I have an ordered map, so everything or every range is ordered here, right? So what I'm essentially doing is going through the entire ordered map and doing the exact same thing, which will this will lead us to only focus on these overlaps instead of going through the entire range. We can just go through the ordered map, right? So what we are doing is basically having a ordered map. This will lead us to the time complexity of O of n log n, but there is a catch which we need to take care, and we'll look at it. To let's have a iterator initialized to the range update begin iterator, and let's have a range end iterator. Alright, and now this will become what? This is the key, or this is the value, right? So this is nothing but iterator second, uh, and we don't have a range update I minus 1 right now. Let's have a last or previous update initialize to 0, and we'll keep updating this previous update so that I can keep track of my previous update basically, and the previous update will now become iterator second, and now the total number of operations will become basically iterator second. This will stay the same, this will stay the same, this will stay the same, and everything will stay the same, just that there is a catch. Since we are going through the map instead of going through the entire range value, we eventually, you know, we might miss out the numbers array, right? Suppose we had a 5 in that array, we might miss out on that, and that will be scenarios where things are not overlapping like this. right? And suppose this particular area had a critical point which was present inside the number. In that case, we will not be able to use that because that is a critical point and that can be an answer. So we have to use that in our answer so that whatever contribution it makes, it should be present inside our answer, right? Similarly here, this is not overlapping and we might have a critical point here. So in that case, we should just update the range for this particular number as well by 0. Why by 0? Because there might be scenarios where it is overlapping. So like this, here we had a critical point, and if we add some value to it, we are going to affect this answer. So I don't want to affect this answer, but I want to iterate over it. That's why I'm adding 0 to it. So that's pretty much it. That's the code, very similar to the previous problem. Let's submit it. Time complexity will become of n log n because we are using map. Oh my bad, range update. I iterated not equal to range update.n. Okay, there is no I. My bad. This should be iterated first. Right? This is the key. So this will become first. This will become first. These are the downsides of copying the code. Yeah, this works. Let's submit it. The fourth problem is quite difficult. I have not yet solved it. And these are the three problems. Thanks.